Good day, class. In this lesson, we will study factoring, but a particular type of factoring. We will learn to factor by grouping. Keep in mind as we proceed that factoring is simply unmultiplying. So if you're thinking of this while you are using this method, then you can always, for the most part, stay on track. Remember, factoring simply means to unmultiply. In terms of factoring by grouping, it's important for you to recognize grouping opportunities. So let's take a look at these two examples. In fact, the example on the left, 2x cubed plus 4x squared, represents a problem that we worked on in the previous lesson. You should recognize this as greatest common factor, where we can go ahead and pull out the greatest common factor of 2x squared and represent what we've left behind, the x plus 2. Make sure you go ahead and multiply that again to double check and make sure you have it right. But the idea is to be able to pull out that GCF. Well, in terms of factor by grouping, it's very similar to GCF. It's simply that you will learn to group your terms. So what we're doing here on the right-hand side, notice how we have 4 terms. That is a key element of factor by grouping. So we recognize the first term as 2x cubed, our second term is 2x squared, and notice how they have a relationship. That 2 and that 2 both have something that we can pull out of there. They have a common factor. Greatest common factor can be found. Also on the third and fourth terms, the 3x plus 3 have a common factor as well. So we can actually group those terms because they're somewhat related, if you will. The 2x cubed plus the 2x squared, and then the 3x plus 3. So I simply group them using a set of parentheses. Remember, this represents factor by grouping. So I'll take a minute to show you how exactly to factor by grouping step by step. Let's take a look at our example. 2x cubed plus 2x squared plus 3x plus 3. As we mentioned a moment ago, we definitely want to recognize this as factor by grouping because we have 4 terms and they can be grouped in sets of 2. Notice how our first set of 2 terms, the 2x cubed plus 2x squared, can be factored by GCF by pulling out that 2x squared, as you see here, and we show what we have left behind. We've left behind the x plus 1. I've kind of covered up the second half of the problem so you can focus on where this has come from. It's just coming from the first 2 terms. 2x squared is the greatest common factor of that binomial, of that polynomial. So we want to pull that out first and then demonstrate what we left behind. Now it's time to look at the other half of our problem. Notice how kind of covered up the first half of the problem so that you can focus on the second half, and I pulled out the greatest common factor of the 3x plus 3. 3 is the greatest common factor of our polynomial 3x plus 3. So once I pull that 3 out, notice how I've left behind x plus 1. Well, this is the beauty of factor by grouping. Whatever you've left behind matches in both cases. So in our first half of our problem, x plus 1 was left behind. The second half of our problem, x plus 1 was also left behind. So always remember to give factor by grouping a try if you notice that you have 4 terms where you can group 2 that have a relationship. So I'm not finished here because I'm actually going to factor this a step further by recognizing that that 2x squared plus 3 are actually going to be one of our binomial sets in this particular problem. So we're actually going to take that 2x squared plus 3 and we're going to combine them into one expression. 2x squared plus 3. And then we're going to represent our x plus 1 as a second part of the expression. We're going to sit them beside of each other and say that they are they can be multiplied again together, and you can certainly double check that, be sure that you do, to represent the 2 binomial factors of our original polynomial. Now I have completed this particular example problem where 2x cubed plus 2x squared plus 3x plus 3 can be unmultiplied, if you will. And when we do that, we end up with what we have on our very last line, 2x squared plus 3, that quantity multiplied by x plus 1. In our next example, there are a couple of things I want to demonstrate here. Notice how I have 4 terms, but there's really no relationship between the 5 and the 3 in terms of multiplying. Also, in my second set of terms, the third and my last term, there are also really no relationship between the 15 and the 9 in terms of finding a common factor. So if I look closely, I should notice that I could rearrange my 4 terms, and there actually may be a relationship that can be found. So make sure you always do that if you notice that there may be an opportunity to factor by grouping. So I've rearranged my terms where I've put the 5x cubed and the 15x squared together so that they can share a relationship, and then also the negative 6x minus 18, I put those together so that they can have a relationship as well. Now I may have some success with pulling out a greatest common factor. So let's go ahead and group these terms. So I've got my first set of terms, my 5x cubed plus 15x squared, and I can pull out my 5x squared. And I've got my 6x minus 18, and I can pull out a negative 6. Now, be very careful here. First thing we notice, or we look for, is to make sure that whatever we've left behind is actually matching in both parts of the problem. So x plus 3 has been left behind in both parts of the problem. So I'm good there. I can check that off. The second part of the problem, notice how I pulled out a negative 6. So it's important that you let that negative unmultiply from that 3 as well. So notice how when I pulled out that negative 6, then the negative came out of the 18, if you will, and left back a positive 3, which allows that x plus 3 to match on both sides of the problem. So if you need to pause this lesson, study it, practice a few problems that look like that, use similar exercise, or try again in your homework, be sure to do that because it's important to practice that. It's a skill that you develop as you begin to recognize that negative pulls out and undoes another negative, and leaving us in this case with a positive 3. And then lastly, I'm going to join the coefficients that we have there of the binomial x plus 3. And so my first coefficient is 5x squared, and then my second coefficient is minus 6, so I'll join those together. And then I demonstrate that I've left back an x plus 3, and so I sit that in a binomial term beside of it. And so now I have 2 binomial terms that represent the unmultiplication of my original polynomial. So the solution is 5x squared minus 6, that quantity, times x plus 3. That quantity. And so what I'm saying is these are the 2 numbers that were multiplied that gave me my original polynomial. Be sure to FOIL that out. Remember, we practiced FOIL in a previous lesson to make sure that you get back to your original problem.